Okay, folks, this is a video about graphing exponential functions, and we're going to start with this basic function. The good news is if you understand this video, then you'll understand most of the other things. It's just a matter of applying it. Now, so this is a simple exponential function. Let's graph it. Let me do this. I'll start with 2 to the 0. 2 to the 0. 2 to the 0 is just 1. This one's 2 to the 1, which is 2. This is 2 squared, which is 4. Okay, so we get that. This is 2 to the negative 1. Remember, 2 to the negative 1 is 1 over 2. That's 0.5. This would be 2 to the negative 2. 2 to the negative 2, or 1 over 2 squared, which is 4, or 0.25. Okay, so let's take these points right here and plot them. Okay, I plotted the points. Now, just like we understand the line, if you have 2 points, separated on a line, there's points in between them. The same thing is true here, that, even though these are integer numbers, I could do 1.5. 1.5. There must be a point here somewhere, or there must be a value for the y. So the way to understand that is to draw a smooth curve, right? Not a line, a curve. Through these points, okay? So now the question is, can I find the values of these other domain values? 1.5. Well, yes, if I go up here to 1.5, it looks like it's about 3. Now you could take your calculator and verify that. This is the graph of the function y equals 2 to the x. It is an exponential function, and as we know, these values, the domain values, continue that way and continue that way. Now, these values continuing this way will get small. They'll get close to the 0, but they won't become 0. And what that tells us is there's a line that the graph or the function is approaching but does not touch. Okay? And remember, that was called an asymptote. So there you go. There's our function. Now, what we need to do is we need to do a tell all. So first of all, what's the domain of this function? Well, it goes to the left and to the right. There's no problem values, so all real. What's the range of the function? Now that's a very good question. The range. Does it go up forever? Yes. Does it go down forever? No. The y values, they don't get to 0, they get close to 0. So you could say y is greater than 0. Remember, not equal because it's not touching. That would be the range. What about an intercept? Okay. Is there an x-intercept here? No. Is there a y-intercept? Yes. The y-intercept is at 0, 1. That makes sense because basically anything to the 0 power gives me 1. Now, if you were an ant on the curve and you were going from domain values from the left to the right, notice your y values would be increasing. So the function is increasing. And another question would be, does the function have an inverse? Well, it passes the vertical line test. It is a function. And it passes the horizontal line test. It passes the horizontal line test. So yes, it does have an inverse. And lastly, what is the equation of that line? The equation of the line that the graph approaches but does not touch. Okay, and that's this line right here. Okay. Remember, it's a left and right line, so it's a horizontal line. It's a y equal line. Y equal what? 0. That would be the asymptote. So this is some information about the function f of x is equal to 2 to the x. And we'll take this function, the numbers, the curve, the way the curve looks, and this information and apply it in other situations. Okay, now notice we have another function, f of x is equal to 1/2 to the x. And the last problem, the base was greater than 1. In this case, the base is between 0 and 1. Let's plug in those values. Let's do the 2 first. Well, 1/2 squared, that's 1/4, which is 0.25. 1/2 to the 1 power is just 1/2, or 0.5. 1/2 to the 0 power, okay, that's 1. Now 1/2 to the negative 1 power, that's just really 1 over 1/2, and we know that is 2. So what about 1/2 to the negative 2 power? Another way to look at that is that's 1 to the negative 2 over 2 to the negative 2. And we need to move this down here, and we need to move that up there. So that's going to give us 4. Can we plot the points? Yes. Okay, so we plotted the points, and so here the curve is going this way, and then it's going back up this way. Remember, the curve is approaching the horizontal line, y equals 0, but not touching. I may not have drawn it that way, but that's the way it's supposed to be. All right, let's do this domain. Domain, again, all real. The range, again, y is greater than 0. Now, what about an intercept? Well, we still got that same intercept, 0, 1. Okay. Also, what about its increasing and decreasing? Notice the curve is going down. So we're going to call that decreasing over the entire domain. And is there an asymptote? Yes, there is an asymptote. Again, it's this line, y is equal to 0. The last one could be called a growth, and this one could be called decay. And the reason why is because its base is less than 1. That's important. Okay, folks, so now what we're going to do is we're going to apply what we know about the function y equals 2 to the x. Notice I have a left and right, an up and down, and I have a stretch. Question, can we graph this function right here? Well, we know that it's up 1, so the horizontal asymptote is going to go this way. Okay, and we also know that this point would have to be part of the function. It's, remember the 0, 1. Okay, if I plugged in a 0 here, it'd be 1 plus 1, which is 2. And can I graph that? Yes. Okay, so that's that function. Now how about this one? How is this different? Well, remember, normally I have 0, 1, and I have 1, 2. But this is saying move the x to the right, move the function to the right. So basically I'm going to take this point, move it over here, and I'm going to take this point, move it over here. And I'm going to get rid of these other points here before I forget what's going on. Okay, and there's my function. You can call this the anchor point. Okay, it really helps you out. Now what about this function? Well, that's a good question. Now remember, there's a minus in the front, so that means it's going to be flipped. Flipped over the y-axis or the x-axis. It's going to be the x-axis. So instead of 0, 1, I'm going to have 0, negative 1. Instead of 1, 2, I'm going to have 1, negative 2. Okay? So there you go. That's that function. Now what about this function? This is a very interesting function. Again, normally we have 0, 1 and 1, 2. But instead of the y being negative here, the x is negative. So instead of flipping over the y-axis, we're going to flip, instead of flipping over the x-axis, we're going to flip over the y-axis. So this is over here, and this doesn't flip, this just flips over itself. Okay, so that's that function. Now you may be wondering, now that function looks a lot like the graph we just graphed, y is equal to 1/2 to the x power. And you are right. How do I know that? Because if you go back and study this, that would be the same thing as 2 to the negative 1 to the x, right? If I use the power rule backwards. But we know that 2 to the negative 1 is just 1 over 2. And yes, these two expressions are equivalent. So that's another way to understand exponential functions. Like I said, it all goes back to this basic graph. And if you understand this basic graph, then you can understand how to do the others. I hope that helps.